Next, we are ready to graph these inequalities. To graph an inequality, you're going to start pretending like it's an equation sign. So ignore the inequality symbol in the problem, pretend like it's an equal sign. Graph it like you usually would. Then you're either going to connect the points on that line with either a solid line or a dashed line. If the inequality symbol is strictly greater than or strictly less than, you're going to be using a dashed line. If it includes an equal sign in the inequality, like greater than or equal to or less than or equal to, that's when you use a solid line. Remember sort of like the open circle and closed circle when we were graphing on number lines? This is similar. Just like the open circle on a number line showed that a cutoff point was not a solution, the dashed line, any of the points along that dashed line, those are not solutions. And kind of like the closed circle on the number line represented points that were solutions, same thing here. A solid boundary line would mean that the points on the boundary line are solutions. Now, after you draw your line, you're also going to need to do some shading. You'll shade one side of the line or the other. And the way you'll figure out how to do that is by doing a test point. Just like with the number lines where we did a test point on either side of that cutoff value and that told us which side of the number line to shade, same thing here. So let's try one here. Remember, your first step is to pretend like the problem has an equal sign in it instead of an inequality, and then you graph it as you usually would. So for this question, I'm going to go ahead and use standard form and find the intercepts since this one's already written that way. Recall that to find the x-intercept, you plug in a 0 for y. So we'd get x plus 0 equals 3, which means that the x-intercept is 3. So I got a 3 for x when I plugged in a 0 for y, and the point 3, 0 is on my graph. Next, I'm going to find the y-intercept by plugging in a 0 for x, and I get y equals 3 when I plug in a 0 for x, which means the point 0, 3 is a point on my graph. Now, before I connect those points with a line, I need to know whether I'm going to connect them with a solid line or a dashed line. Recall that anything that's a strictly greater than or strictly less than, that's going to be a dashed line. So I'm going to be connecting these points here with a dashed line. That means that all of those points along that green dashed line are not solutions to the inequality. The last thing I need to do is shade one side or the other. And I like to pick 0, 0 as my test point because it's easy to do calculations with. However, you can pick any point you want as long as it is not on the line. So if your line would happen to go through 0, 0, you would need to pick a test point other than 0, 0. So I'm going to use 0, 0 for my test point, which means I'm going to be plugging it into the original inequality. Remember, the first coordinate is your x and the second coordinate is your y. So instead of x plus y, we're going to have 0 plus 0. And I end up with 0 is greater than 3, which is a false statement, which means that my test point is not a solution. So all of the points over here are not solutions. I just have to test one, and the same true or false outcome would be true for the rest of them. So none of these points work. That means the points on the other side will work. So all of these points are solutions to my inequality x plus y is greater than 3. That includes all of these kind of grid points like the whole numbers and integers, but it also includes decimal values and fractions in between the squares. Every single point in that green shaded area would result in a true outcome here. If you wanted to be overly kind of sure about yourself, you could pick a point in this other side of the line, like maybe the 0.40, if you wanted to do a second test point just to check. So put in the 4 for x and a 0 for y, and we get 4 is greater than 3, and you can see that that does work.